Hello, today we're going to talk about synthetic division, and we're going to use synthetic division to validate roots. But first, we have to learn how to divide using synthetic division. So if we look at the first example, where we have a divisor of x plus 5 and a dividend of x cubed plus 9x squared plus 23x plus 15. Now I'm going to give myself a little bit more room. So the first thing we're going to look at is if we had x plus 5 equals 0 and we solve, we would get x to be negative 5. So that's what we're going to use in one part of setting up. Negative 5, we'll put that in the box. Now we're going to use each of the coefficients. So we have a degree of 3 and we want to use the coefficient for each of the remaining powers. So we have a coefficient of 1, 9, 23, and 15. So if there was a power that was missing, we would fill in a 0 for it, and we'll do an example of that later. So we have two different levels. Okay, so this second level, each value here we're going to add, and on the bottom we're going to multiply. The first number will always get dropped, so 1 always comes to the bottom in this case. It could be any value though, so the first number is always going to get dropped. Now we're going to multiply any value that's down in this third level by negative 5. So 1 times negative 5 is negative 5. So now anything on this level we're going to add. So 9 plus negative 5 is 4. Now we'll multiply. 4 times negative 5 is negative 20. Then we'll add again. 23 plus negative 20 is 3. And we'll multiply. 3 times negative 5 is negative 15. And 15 plus negative 15 is 0. So this last column always tells me my remainder. So we have a remainder of 0, which will confirm that x plus 5 goes into this polynomial evenly, and negative 5 is indeed a root. So we have a polynomial here on the bottom that we can write based on this degree is 3. So we'll always take 1 less, and these will be our coefficients. So we got a degree of 3. So we're going to start with the square. So x squared plus 4x plus 3. That would be the remaining polynomial. So this 0 also indicates if we were to substitute negative 5 in for x, you would get a 0 for your evaluation. But the important thing here is then using synthetic division to validate roots. If you get a remainder of 0, it is indeed a root. Let's look at our next example. Excuse me. Here we have x minus 3. So we're taking the opposite, which is going to give us x equals 3. So that's what we're going to use. And again, we have a degree of 4 here, but we're going to take all of the coefficients. But notice there's no constant here. So we have to put a 0 on the back end. So our coefficients are going to be 1, 3, negative 13, negative 15, and we'll have to account for the 0. So we'll have the level in which we're going to add everything, and on the bottom we're going to multiply. So again, drop the first number, which in this case is 1 again. So 1, now we'll multiply 1 times 3, 3, add 3 and 3 is 6, multiply 6 times 3, 18, add negative 3 and 18 is 5, 5 and 3 is 15, negative 15 and 15 plus 15 is 0, anything times 0 is 0, and then when we add for the remainder, again we get a 0, which indicates that 3 is a root. Okay. So if we go back, there are 2 other examples that we want to look at. Here we have x plus 5 again. So negative 5 is going to be our root that we want to confirm. And we have 1, 10, and 18. Ooh, that wasn't very good. Here we go. So again, we're going to drop the first number and then multiply. 1 times negative 5 is negative 5. We're going to add 10 plus negative 5 is 5. 5 times negative 5 is negative 25. 18 plus negative 25 is negative 7. So because we got negative 7 instead of 0, that tells me that x plus 5 is not a factor. And negative 5 is not a root or 0. Okay? So on 4, we have x cubed plus 27. Now remember, everything has to be accounted for. So we really want to look at this as x cubed plus 0x squared plus 0x plus 27. Because all the powers have to have a coefficient. Okay, so because we have the plus 3, we're going to use negative 3. And now write all of our coefficients. So we got 1, 0, 0, and 27. So remember everything on the second level, we add, and on the bottom level, we multiply. So we're going to drop the first number. 1 times negative 3 is negative 3. Add, we get negative 3. Multiply, we're going to get a positive 9. Add, we get another positive 9. Multiply, we get a negative 27. And when we add, we do get a remainder of 0, which confirms that negative 3 is a root, or 0. And x plus 3 is a factor. So now we're going to take our knowledge of synthetic division and use that to confirm zeros and find the other zeros either by factoring or using other forms, other ways that we know how to solve quadratic equations. So as we touched on before, our fundamental theorem of algebra tells us that our degree will tell us the number of zeros. And keep in mind, those could be real or imaginary. Remember, imaginary always comes in pairs. So use Desmos and graph the x cubed plus 3x squared plus 16x plus 48 to find a zero. So you should see a 0 at -3. Well, let's confirm that using synthetic. So we're going to take our -3 and now our coefficients. So we got 1, 3, 16, and 48. So we're going to drop the first number and then multiply. Add and multiply. Add and multiply. Add, and we get a remainder of 0, which indeed verifies that -3 is a 0. But now we can take what's left, given that we started with a cube or degree of 3, so we know the remaining polynomial is x squared. We got 0x and then a constant of 16. So we got x squared plus 16. So we can solve that using our square root method. So x squared is going to be equal to -16. And we'll square root both sides to get x is equal to plus or minus 4i. So we have all of our zeros in this case. We confirmed the -3 using synthetic, and we have plus or minus 4i. So based upon our fundamental theorem of algebra, we have all 3 of our zeros. Okay, let's try another one. So graph this polynomial, find a 0, and verify using synthetic. Okay, so we should have noticed from looking at the graph that we have a double root at 1. So we can do synthetic twice because it's a 0 twice. So we're going to use 1 and using the coefficients of 1, -4, 8, -8, and 3. So we're going to drop the 1, multiply, add, multiply, add, multiply, add, multiply, add, and we do indeed get our remainder of 0. And because it was a double root, we can now use this polynomial in the same 0 because it was a double root and do it again. So we'll still use 1, but now we're going to use 1, -3, 5, and -3. So we're still going to drop the first value. Now multiply, add, multiply, add, multiply. When we add, we get our second remainder of 0. So now we're left here. We started with a 4th degree polynomial. So this would be a cube. So we could say that this is x cubed minus 3x squared plus 5x minus 3. So now this is a cube, so this is going to be a square. X squared minus 2x plus 3. So to find the other two zeros, it cannot be factored. So we're going to have to use the quadratic formula, where A is going to be 1, B is going to be -2, and C is going to be 3. So we got x is equal to +2 plus or minus the square root negative 2 squared minus 4 times 1 times 3 all over 2 times 1. So positive 2 plus or minus the square root of 4 minus 12 all over 2, or 2 plus or minus the square root of negative 8 over 2. So 2 plus or minus 2i square root of 2 over 2, which is 1 plus or minus I square root of 2. So again, we're going to have a total of 4 zeros based upon our fundamental theorem of algebra, because our degree is 4. So we had a double root at 1, so that counts twice. So x is equal to 1, and we verified it using synthetic. That's a double root, and we also have 1 plus or minus I square root of 2. So there are other 2, which are imaginary, for a total of 4. So hopefully this gives you a good idea of how to divide using synthetic division and how to use it to validate zeros and find